So first you see the laboratory and then go to the museum. Right? So Shankar sir will explain instruments they can see. Here inorganic analysis. All the inorganic analysis we will do. Right? And one by one, sir Shankar sir will explain you. We'll go and see that. Don't touch anything.
Mass spectrophotometer, ICP-MS. We call it as ICP-MS. Previously, what we used to think is iron is very useful, gold is very useful. There are all traditional metals, iron, cobalt, chromium, copper. Copper we use in electrical fittings. So all these things, they have so many domestic uses are there. Without iron, man cannot live because the iron. So construction of the precious. So nowadays, people are thinking about the exploration of REE, rare earth elements, because their uses are very, very high. And unfortunately, their presence is very, very less in earth crust. So whatever metals you are getting from your earth crust only you are getting. So these REE, they are available in earth crust in a very small quantity. If you see throughout the world, actually, China is leading. Why China is leading? Because it is able to explore lot of REE, rare earth elements from the soil or rocks. So it is the biggest producer of rare earth elements in the world. And India is about in 5th position. Second position, Australia and some other countries are there, and India is in 5th position. And unfortunately, USA, United States of America, it is purchasing REE either from Australia or from China. Now what happened? China has stopped by giving their products, these REE products to other countries. They put a ban. Now that's a problem. Now India is facing a problem. They want REE to prepare or to manufacture high-end equipment. So that's why Geological Survey of India, we are very much interested in the exploration of rare earth elements. So the thing is, this is the only one and only instrument available in the analytical world to analyze your rare earth elements. So before going to extract rare earth elements, you should know what is the range of rare earth element in those rocks. So for that, what you have to do, you have to analyze those rocks using one analytical instrument to know how much rare earth element is there. For that, this instrument ICP-MS is required. So, and in addition to rare earth elements, why uranium is important? Why uranium is important? Uranium is also very important for developing countries. To produce electricity, we are from Tamil Nadu, Kalpakam,
nuclear power reactors.
Very famous this thing, Kalpakam. What Kalpakam will do?
Nuclear reactor.
Nuclear reactor is there. 7% of electricity we will get from your state. That Kalpakam they produce by bombarding your uranium with these neutrons, and because of that chain reaction, you will get energy. It is nothing but your electrical energy that we are using. So uranium is also very, very important for India to produce electricity. So at the same time, how much uranium is there in your earth? How you will know? With the help of this instrument. So this instrument is mainly useful to know or to assess the amount of rare earth elements present in your rocks, soils, stream sediments, any geological material, and uranium and thorium concentration also you can measure with the help of this instrument. Okay? So, what is the use of ICP-MS instrument? You tell me. How it is useful? To know the concentration of uranium, thorium, and rare earth elements, 14 elements are there. They are very, very precious, very costly. Just like your platinum, palladium, gold, nowadays lanthanum, cerium, all these things are also very valuable material. So, to know the amount of those things in geological material, this instrument is required. Now, next point, how we measure in this instrument? What is the process? Whether we can put that sample or geological material directly into the instrument? No. This instrument will take only liquid. But you have solid sample is with you. So first step in the analysis of rare earth elements is you have to convert that solid into liquid. How to convert that solid into liquid? Any geological material, there are two internationally accepted methods are there. By digesting with very, very strong acids, it is one method. The other method is by digesting the samples, geological, very tough samples with alkali fusion with lithium metaborate and lithium tetraborate in platinum crucibles. So what we will do is, even strong acid digestion is also not sufficient to dissolve your geological material. So what we will do is, we will take 0.1 gram of sample, geological sample, we add 0.3 grams of lithium tetraborate and metaborate, we will put it in furnace, muffle furnace at 1000 degrees centigrade for 1 hour. After some time, you will get glassy like material will come and we will dissolve it in acids, different dilute acids, and everything will come into solution. That solution we introduced into this ICP-MS. And this, if you see one white color bulb-like material you are able to see. You know what is that one? It is called plasma. It is called plasma. How you will get plasma? By bombarding argon gas with electrons, you will get plasma. Do you know the temperature of that plasma? It is 10,000 degrees temperature. 10,000 degrees.
30,000 you can't tolerate it.
10,000 degrees temperature you are able to produce in ICP-MS. Why that much of temperature is required? Because your REE are very, very resistant material. To activate that one, you require very, very high temperature. So for sodium, potassium, they are easily evaporatable. That's why by using your ordinary gas, LPG gas, by plasma, and in that plasma, everything will be converted into ions. And here detector is there. Detector will find out how much of lanthanum is there, how much of cerium is there, and finally it will give the report, concentration of different RE materials present in your sample. So this is the process, and the cost of this instrument is around 3 crore rupees, and maintenance per year about 50 lakhs to 1 crore rupees for the maintenance of the instrument we require. For this very high grade water is required, that is called milli-Q water, actually very, very high grade. River, what will be the TDS of that river water? How much dissolved solids will be there in your river water? About 200 ppm. If you collect sample from your sea, how much TDS will be there in your sea water? It will be around 50,000. So, like that. But we need zero concentration. Only H2O should be there. For that, you require one instrument, that is milli-core water purifier, ultra water purifier. It costs about 70 lakh rupees. It costs about 70 lakh rupees. So, this maintenance is very, very, very high. So, GSI is a internationally reputed laboratory, just like United States Geological Survey, USGS we call, same level. GSI is also same level. Every year we are participating in international proficiency testing. That means, say, for example, from this, because I am the director of this laboratory, I can say my analysis is excellent, but it has no meaning. We have to participate or compete with international agencies, because they will send one sample to the America, Japan, Canada, India. So from India, we are representing. We analyze those samples and send it to the international agency. Finally, they will check and they will give you one certificate that your efficiency is 100%. Every year, for the last 7-8 years, we are participating and we are getting 100% efficient certificate from the international agencies. So, our results are internationally reputed results, just like America and all these things. So, this is the reputation of this laboratory, and we have published so many international papers. We regularly went to the foreign countries.